കേൾക്കാൻ പറ്റുന്നുണ്ടോ? എന്നെ കേൾക്കാൻ പറ്റുമോ? കേൾക്കുന്നുണ്ടോ?
ആ സാറേ കേൾക്കുന്നുണ്ടോ?
So let us start. ഇന്നൊരു പ്രതിജ്ഞ കൊല്ലാറുണ്ട്. അത് ചൊല്ലിക്കൊണ്ട് നമുക്ക് ആരംഭിക്കാം. നമ്മുടെ കേരളത്തിലായിരുന്നു സ്ക്രീൻ കാണുന്നുണ്ടല്ലോ അല്ലേ? സ്ക്രീൻ കാണാലോ? ഇതൊന്ന് നോക്കിയിട്ട് വായിക്കാം കേട്ടോ. പ്രതിജ്ഞ അയച്ചല്ല, ഞാൻ വായിക്കുന്നത് അതേപോലെ ഏറ്റു പറയാം കേട്ടോ. മലയാള ഭാഷ വാരാഘോഷം. പ്രതിജ്ഞ. കേരളം ഞാൻ പിറന്ന നാടാണ്. പറയാം, എല്ലാരും പറഞ്ഞു. കേരളം ഞാൻ പിറന്ന നാടാണ്. മലയാളം എന്റെ മാതൃഭാഷയാണ്.
മലയാളം എന്റെ മാതൃഭാഷയാണ്.
എന്റെ ഭാഷ എന്റെ വീടാണ്.
എന്റെ ഭാഷ എന്റെ വീടാണ്.
കേരളപ്പിറവി ദിനം.
കേരളപ്പിറവി ദിനം
ഓരോ മലയാളിയും ആഘോഷിക്കേണ്ട ദിവസമാണ്. കേരളത്തിന്റെ ഭാഷയും സംസ്കാരവും ഓരോ മലയാളിയുടെയും വ്യക്തിത്വത്തിന്റെ ഭാഗമാണ്. ലോകത്തിന്റെ ഏത് ഭാഗത്തും അധിവസിക്കുന്ന മലയാളിക്കും ഗ്രഹാതുരത്വം ഉണർത്തുന്ന ഓർമ്മയാണ് കേരളം. കേരളത്തിന്റെയും മലയാളത്തിന്റെയും ആന്തരിക സത്തയെ ഞാൻ ബഹുമാനിക്കുന്നു. മാതൃഭാഷയുടെ പുരോഗതിക്കും വളർച്ചയ്ക്കും വേണ്ടി ഞാൻ യത്നിക്കുന്നതാണ്. മലയാളിയായി ജനിച്ചതിൽ ഞാൻ അഭിമാനം കൊള്ളുന്നു. എന്റെ ഭാഷ ഞാൻ തന്നെയാണ്. നീയും ഇവിടെ അല്ലല്ലോ അല്ലേ? Okay, let us start. We are discussing in this semester the reliability theory, the basics of reliability theory. Actually, this book is written by Barlow and Prostad. It's a very rare collection. I have collected from Cochin University in 2004. So that is the reason for the visual problem in this chapter. Okay, blur. There is the visuals are blurred. Anyway, you can understand the concept using this book. It's a very wonderful book, and it is not available in the market. It is only available photostat copy from my own book. Okay, or you can take photostat from Cochin University. The students from our department taken photostat from my book. So the status of book became this what is that this condition. Okay, anyway, we can discuss reliability theory based on this book. It's a research book, and moreover you can use for your studies. In MSc Statistics, we are studying the entire chapter of this book. Okay, but in your study, that means in degree, we are studying only, I think, 1, 2, 3, 4 chapters, the preliminary chapters. That means we are studying an introduction of reliability theory. Okay, sometimes you might have heard about the components and system. In your hand you have a system, that is either it may be a computer, or it may be a what is a mobile phone, or it may be a what is that tab, etc. So that are usually called as systems. Okay, so a system is made up of different components. For example, for a computer is made up of CPU, monitor, it is a speaker is there, and so several systems are made up of several components. For another example is, you consider a radio system. In a radio system, you can see that what are the components of the radio system. What are the components of radio system? A radio system will have a what is that mic, another is amplifier, another is speaker, tuner, changer, etc. So that is the components of radio system. Okay, system structure. Okay, this is a structure of radio system available in our research. This is some structures. Yeah, here you can see the system. So there are several graphical representation of radio system. This is a radio system. There are several components. Antenna is there. This is changer, or what is that? This is input network. It consists of mic and this is the amplifier. This is signal processing. So like as you can see, several type of radio system. Usually in the radio system, that consists of what are the components? Changer, tuner, amplifier, speaker. That are the basic components of radio system. Apart from that components, we can add more components. And so I mean, a system consists of is made up of a combination of different components. So we are considering the systems like radio system or computer or electronic devices, etc. So in that case, we will have components, and we will have system. We can replace the components. If a component is failed, we can replace the component. Okay, suppose the speaker is is damaged. What will we do? We will purchase another speaker and put on this system. Okay, if the UPS is damaged, and what we will do? So we will either put in maintenance, or we will purchase another one. Okay, if our mobile phone is is getting complaint, what we will do? We will purchase any other one, or we will put in maintenance activity, or repair or replacement activity. Okay, so that type of activities we are doing in daily life. So we are studying about the structure of such systems, and the reliability of such a system. How to compute the reliability? That means how it is. What is that? How can we trust in this system? Is it 1 year warranty or what is that? You might have heard about the warranty of different system. You you can see that 6 month warranty will be there for a phone. 1 year warranty, 2 year warranty, 3 year warranty will be there for computers. Okay, so for a light bulb, you can see warranty period, 1 year warranty, or 2 year warranty, etc. So how can we compute this warranty period? Yeah, that is based on the reliability. That means 1 year warranty means the system or the component is reliable up to 1 year, almost surely. Okay, almost surely the system will be, or the component will be reliable, or 95% reliable, or 90% reliable, etc. ലേബിൾ എന്ന് പറഞ്ഞാൽ മലയാളം വേർഡ് വിശ്വാസ്യത എന്നാണ്. വിശ്വസിക്കാൻ പറ്റുന്നു. റിലയബിലിറ്റി, വിശ്വാസ്യത. ഓക്കെ, so we are studying. So we have to find out. Sometimes we have to find out the reliability of the system. Okay, I have shared one book which consists of the studies of reliability theory. Okay, when we look at the index of that book, you can see that. Chapter 1 is multi-state Kyoto system. Reliability system of multiple failure mode, series system, parallel system, parallel series system, series parallel system, Kyoto system, fault tolerant system, etc. And there are consecutive case of Kyoto systems, weighted care. So these are very common in reliability literature. Multi-stage system, combination reliability optimization. So these are some systems we are seeing in daily life. Okay. Most of the researchers in reliability theory are engineers. Why it is happening? Yeah, the system and its engineering is studied by industrial engineers, mechanical engineers, electrical engineers, computer engineers, etc. So you can see several journals in the field of reliability theory. If we look in the Google, you can, if you search in the Google, you can see that several researchers are involved in active research in the area of reliability. Okay, so that is the reason I told you this is a research book. This consists of summarization of various research conducted by researchers for development of reliability theory. Okay, so I told you some examples, and I think you could understand the system structure. So let us put in mathematical form. Okay, let us in order to analyze this type of systems, we have to define structure at first, and then we have to study structure like this. Okay, we have to split into different structures, and then we have to analyze the system. Okay, so that is the reason for considering this type of diagrams. Okay, engineers are studying on this type of diagrams. They are not studying in this type of figures. They are studying this type of diagrams. In electronics, you can see several diagrams. They are studying only diagrams. Okay, so based on that diagram, we can understand the system, analyze the system. That is the idea. So to analyze the system, we need to model mathematically. That is the fundamental requirement of analyzing engineering systems. Okay, so for that, let us consider there are n components in a system. Okay, there are n components in a system, and each component have two modes of states. That is, component may be in functioning stage or maybe in failed stage. So we call it as binary components. Binary components. What is the reason of calling as binary component? So they have two modes of performance. What is component? Either component may be in a functioning state or component may be in failed state. Okay, when we check our system, when we check our computer, you can see that our component may be in functional status or component may be in failed status. So we are considering only two states, but there are some other systems like power generation system. It will have more than two state of performance. My research concentrated on multi-state systems. Okay, uh, I studied this book for the for my research, and my research are in multi-state systems. Okay, so these are so this is the modeling. Let us consider uh, n variables x1, x2, etc., xn. What is x1? X1 is a representation. X1 is a representing variable that represent what representation? Yeah, it is 1 if the component I is functioning, equal to 0 if the component is failed. So there are two modes of performance. We can assign a value 1 and 0 to some component, so some variables that means x1, x2, xn. X1 means the first component state of the first component. X1 is the state of the first component. That means state will be either 1 or 0. 1 if the component is functioning and 0 if the component is failed. Okay, I going from 1 to n. So similarly, we can consider all other components x1, x2, etc., xn. Okay, so that is the component structure. You know, a system consists of components. System is made up of as a configuration or series. It may be as a parallel system. It may be a series system, etc. Parallel system means the components are connected in parallel. Series system means the components are connected in series. Okay, so we can consider a system. So the system will also have a performance. That means it may be either functioning or failed. ഒരു CPU ഫെയിൽ ആയി കഴിഞ്ഞാൽ സ്വാഭാവികമായിട്ട് സിസ്റ്റം ഫെയിൽ ആയി. അപ്പോൾ കമ്പോണന്റ് ഫെയിലിയറിനെ ബേസ് ചെയ്തിട്ട് സിസ്റ്റം ഫെയിലിയർ നമുക്ക് ഡിഫൈൻ ചെയ്യാം. സോ വി ക്യാൻ ഡിഫൈൻ എ വേരിയബിൾ ഫോർ സിസ്റ്റം ഇറ്റ്സെൽഫ്. ഓക്കെ, ദാറ്റ് ഈസ് ഡിനോട്ടഡ് ആസ് ഫൈ. ക്യാൻ യു സീ ദിസ്? കാണാൻ പറ്റുന്നുണ്ടോ? ക്ലിയർ അല്ലേ? കാണുന്നില്ലേ?
ക്ലിയർ ആണ് സർ.
ഓക്കെ, അപ്പൊ ഡിസ്കഷൻ ശ്രദ്ധിച്ചാൽ മതി, അപ്പൊ നിങ്ങൾക്ക് അത് പിന്നെ മനസ്സിലാവും. കുറച്ചൊക്കെ ബ്ലാൻഡ് ആണ്, കുഴപ്പമില്ല. സോ ദ സിസ്റ്റം ക്യാൻ ബി കൺസിഡർഡ്.
പക്ഷേ ക്ലിയർ കുറവാണ്.
അത് കുഴപ്പമില്ല, അത് പഴയ പുസ്തകം കൊണ്ടാണ് കേട്ടോ. ഓക്കെ ഓക്കെ. So we can consider system as a we can consider variable for the system itself. Okay, phi is the state of the system. Phi represent, it is a variable, it represents the state of the system. The system can two performance state, that is 1 if system is functioning and 0 if the system is failed. So the component as well as the system are binary variables. The state of the components are represented by x1, x2, xn, where each xi equal to 1 or 0 according as functioning or failed. Okay, the system is functioning or failed if the state of the system is represented by phi, that equal to 1 if the system is functioning, equal to 0 if the system is failed. The failure may be due to the failure of any of the command. Okay, so binary variable. So xi's are binary and phi's are binary. Phi is also binary. Xi's are binary, phi is binary. Okay, so component state and system state are binary variables. Below we can see some representation. Phi can be represented as phi of x. What it means? Phi is a function of component state. System state depends upon the component state. If system if any of the component is failed, then the system may be in failed state. So we can represent phi equal to phi of x. That means phi is a function of x, where x equal to x1, x2, etc., xn. So this function, this phi is usually called structure function. Okay. This is usually called a structure function. Okay. Or we will call it as structure. We will leave the term function. In short form, we will call it as structure. Either structure function or structure. Okay. Here we can see two examples. Very simple examples. One is series system. What is series system? The components are connected in series. Okay. So what will be the life of this series system? What will be the life of the series system? നിങ്ങളുടെ കയ്യിൽ ഒരു മാല ഉണ്ടെന്ന് വിചാരിക്കും അല്ലേ? ആ മാല നിങ്ങൾ വലിച്ചു കഴിഞ്ഞാൽ അത് പൊട്ടും. അപ്പൊ മാല ഫെയിലിയർ ആയി എന്ന് പറയാം. എവിടെയായിരിക്കും പൊട്ടുക? ഏറ്റവും വീക്കസ്റ്റ് ആയിട്ടുള്ള ഒരു കണ്ണിയായിരിക്കും ആദ്യം പൊട്ടുന്നത്. സോ ഏതായിരിക്കും ഇതിന്റെ ലൈഫ്? വീക്കസ്റ്റ് കമ്പോണന്റ് ആയിരിക്കും ഇതിന്റെ ലൈഫ്. ഓക്കെ. സോ ഇഫ് xi equal to 0, if any one of xi equal to 0, then the system will fail. ഓക്കെ. അതുകൊണ്ട് നമുക്ക് അതിനെ മിനിമം ഓഫ് x1 ഏതാണോ ആദ്യം 0 ആകുന്നത് അപ്പോഴായിരിക്കും സിസ്റ്റം 0 ആകുന്നത്. അപ്പൊ അതുകൊണ്ട് അതിന്റെ റെപ്രസെന്റേഷൻ നമുക്ക് മിനിമം ഓഫ് x1 x2 xn എന്ന് പറയാം. ഓക്കെ. മിനിമം ഓഫ് സിസ്റ്റം സ്ട്രക്ചർ ഫംഗ്ഷൻ നമുക്ക് എങ്ങനെ പറയാം? മിനിമം ഓഫ് x1 x2 xn. If x1 equal to 1, x2 equal to 1, etc., xn minus 1 equal to 1, and xn equal to 0, then system will fail. So ഇത് മാറ്റാൻ പോകുന്ന പറഞ്ഞാൽ പിന്നെ സംസാരിക്കും.
ആള് പറഞ്ഞില്ലേ
ഓക്കെ. അപ്പോ ഒരു മാലയുടെ അത് മനസ്സിൽ വിചാരിച്ചാൽ മതി. ഓക്കെ. അപ്പോ if x1 equal to 1, x2 equal to 1, etc., xn minus 1 equal to 1, then xn, if xn equal to 0, then entire system will be 0. So how can we represent that concept? Yeah, that can be represented by product I from 1 to an xi. Okay. If any one of xi equal to 0, then product will be 0. Then automatically phi of x will be 0. Okay. So for a series system, we can represent the structure function of this entire system as minimum of x1, x2, xn. That means any one of, at least one of component failure is at least one of the component is becoming failed. Then what will happen? The system will also become failed. Okay. So in that case, we can represent the system structure as minimum of x1, x2, etc., xn. Okay. That can be represented mathematically as product I from 1 to an xi, because when any one of the xi equal to 0, then it will become 0, or at least one of xi, 1 or 2 or 3 xi equal to 0, then the product will be 0. When all xi's are 1, that means the series system will be in working stage. Then we can see that the product will be 1 and phi of x equal to 1. So that is the idea. Okay.
സാറേ സീരീസ് സ്ട്രക്ചറിന്റെയും പാരലൽ സ്ട്രക്ചറിന്റെ ഐഡിയ ഒന്നും കൂടി പറഞ്ഞു തരുമോ? മനസ്സിലായില്ല.
ഞാൻ ഒരു പെയിന്റിൽ എടുത്ത് കാണിച്ചു തരാം. പെയിന്റിൽ insert. So let us consider x1. Okay. x1 equal to 0, comma, and all other components are in working state. Okay. ബാക്കിയെല്ലാം 1 ആണ് കേട്ടോ. Equal to 1. Okay. Then in this case the system will fail because the first component is already failed. Okay. In this case the system is failed. So what is the state of the system? 0. That will be the minimum value of this one. Minimum of 0, 1, 1, etc. 1. So in this case system fails. So in this case the 5 will be taking value 0. So how can we represent? How can we take the 0? 0 is nothing but minimum of these values. So we can represent 5 as because system fails if at least one of the x's are 0. So the 5 will be 0. If 2 components are failed, then also we will have the system sector value 0. If 3 components are failed, then also we will have 5 equals 0. So if at least one of the component is failed, then the system will be in failed state. So instead of writing this one, we can in this case we can write the system sector as minimum of x1, comma, x2, comma, etc. xn. Okay. So moreover, one more case is there. Suppose this x1 is also 1. Then what happens? Okay, this is one case. This is another case. Okay, then what happens? The system value will be 1. So what will be the minimum value? Minimum of x1 xn will be equal to 1. In this case also minimum of x1 xn will be 0. Okay. If at least one of x's are 0, then the system will be 0. That means this can be mathematically represented minimum of x1 xn equal to 0. If all the components are in working state, then the system will be in working state. That means minimum of xn. If all the components are having value 1, then minimum will be also having 1. So that can be represented like this. So instead of representing like this, we can represent minimum of x1 xn for the structure function. Again, we can think that what is minimum in the case of binary variables? Instead of writing minimum of x1 xn, we can write as, what is that? We can write as, I going from 1 to n xi. Okay, xi, I going from 1 to n xi. So this product xi will be 0 if at least one of xi equals 0. This product xi will be 1 if all xi's are 1. Clear level? Okay.
Clear right, sir.
That's idea. So in the case of parallel system, then what happens? Parallel system. Okay. Parallel system. In the case of parallel system, that means components are connected in parallel. We can consider a parallel system. തൃശ്ശൂർ സെന്റ് തോമസിൽ നിന്ന് നടുവിലാലിലേക്ക് പോകാൻ വേണ്ടിയിട്ട് ഏതൊക്കെ വഴികളുണ്ട്? തൃശ്ശൂർ സെന്റ് തോമസ് കോളേജിൽ നിന്ന് നടുവിലാൽ സ്ഥലത്തേക്ക് പോകാൻ ഏതൊക്കെ വഴികളുണ്ട്? ഏതൊക്കെയാണ് വഴികൾ? ഇവിടെ ഉണ്ട്, പാലസ് സിസ്റ്റം കാണാം. തൃശ്ശൂരിന്ന് ഇവിടെ സെന്റ് തോമസ് ആണെന്ന് വിചാരിക്കുക. സ്പോട്ട് സെന്റ് തോമസ്, ഇത് നടുവിലാണ്. അപ്പോൾ നമുക്ക് ഇതിലേക്ക് പോകാം. ഇങ്ങനെ റൗണ്ടിന്റെ ഇതിങ്ങനെ പോകാം, അല്ലെങ്കിൽ അമ്പലത്തിന്റെ അതിൽ കയറി പോകാം, അല്ലെങ്കിൽ പാരലൽ സിസ്റ്റം, അല്ലെങ്കിൽ എ സിഗ്നൽ ക്യാൻ ട്രാൻസ്ഫർ. ഇതിപ്പോൾ ടവറുകളാണ് ഇരിക്കുക, ടവറുകൾ, ഡിഫറെന്റ് ടവേഴ്സ്, സിഗ്നൽ ട്രാൻസ്മിഷൻ ടവേഴ്സ്. So a signal can pass through either any one of these tower. Okay, so that is parallel connection. So we have to find out the structure of a parallel system. For that we will consider, this is a notation. So you can see that if at least one of the component is functioning, for a signal transmission of the area, suppose a radio transmission system, for a signal transmission, if at least one of the tower is functioning or signal transmission node is functioning, then the signal will pass through that node. Okay, so the requirement is at least one of the component is functioning. Okay, റേഡിയോ സിസ്റ്റം സാധാരണഗതിയിൽ 2 സ്പീക്കർ ഉണ്ടാവും. ആ സ്പീക്കറിൽ ഒന്ന് കേടായാലും കുഴപ്പമില്ല. യു ക്യാൻ ലിസൺ ടു ദി റേഡിയോ സിഗ്നൽസ്, ഓക്കെ, യൂസിങ് വൺ സ്പീക്കർ. സോ ദാറ്റ് ഈസ് ഐഡിയ. സോ ദ കൺസെപ്റ്റ് വിൽ ബി at least one of the system, at least one of the component is functioning. Okay, that is the idea of parallel system. So how can we represent mathematically the structure function of a parallel system? That is there is a representation for that. You know, the values of the components state are 1 and 0. Okay, I will show you another. Suppose there are 2 components, component A and component B. If both of the components are working, then the system will be also working. Okay, I'm going to represent here. This is X, this is Y, രണ്ടാമത്തെ കമ്പോണന്റിന്റെ സ്റ്റേറ്റ്, ഇത് സിസ്റ്റത്തിന്റെ ക്യാപിറ്റൽ S. Okay, if component X and Y, X and Y are in parallel. So if component X and Y are in working state, then usually you know that the system will be in working state. So we can represent it as a 1. If component X is working and the component Y is in failed state, then what will happen? Since the system is parallel, if any one of the component is working, then the system will be in working. Okay, so we can represent 1. If the component X is 0 and the component Y is in working state, then also similar situation arises. What happens? Any one of the component is working, so the system will be working. If both the remaining chance is the both components are in failed state, surely the system will be in failed state. So what are the values? This is the value. This is exactly equal to maximum of what is that? 1, 2. Okay, is it right? Yeah, we got exactly this is actually maximum. Okay, so we got the system set as maximum of x1 x comma y. Right, so this the one is here, one is here, again one is here, system structure, system value 1 is here. So here one is here also we have 1. Here we have 1, 0. Here also we have 0. So similarly, we can see that in the what is a system structure is exactly equal to maximum of x comma y. In the case of binary system, so we can represent the system structure as maximum of x comma y. But at the same time, how can we represent maximum? That is a mathematical tool that is actually maximum can be represented as 1 minus x into 1 minus y. So instead of writing maximum of x comma y, as in the series system, we have written product for instead of minimum of x comma y. So in the case of parallel system, we have to represent as a mathematical form for the analysis. When we represent like this, we can do the mathematical analysis using addition, multiplication, division, etc. But we cannot do many mathematical analysis using maximum representation. So instead of we writing like this. So let us try to find out the value. What is that? 1 minus x into 1 minus y. Okay, what is 1? Similarly, we can find all other values. So instead of writing maximum x comma y, we can write 1 minus x into 1 minus y. So that is the idea. So we can represent the structure function of a series system as this is a representation. Yeah, union xi. Union xi means 1 minus product I from 1 to n, 1 minus xi. Or in other words, 1 minus x1 into 1 minus x2 into etc. 1 minus xn. So instead of writing this type of representation, we are writing like this. That can be this notation is given to that representation. So we use that notation. This is only notation. There is no mathematical analysis involved. So this is only notation. Instead of writing this one, we are writing this. Okay. So that is the structure function of a parallel system. So we have studied structure function of a component, structure function of a system, as a special case, structure function of a series system and parallel system. You can write all these notes using this page and the previous page, and you can submit in the Moodle platform. And there are K-out of system and remaining remark is there. Some examples will be there, so that will be discussed in the next class. Okay. Anyway,
Okay, sir.
anyway, I have recorded this video, and I will try to give you using YouTube platform. Okay.